What up, you fellas? It's your boy Wolf Said the Engineer, and this is Kerbal Tutorial. Okay, so I'm gonna teach you guys how to make an SSTO in the simplest way with the basic technology. So I'm starting with the MK cockpit and the cargo bay. So the idea of this airplane or the SSTO is to go to orbit, to take off, to go to orbit and come back in one piece using the basic basic flight maneuvers. Okay, so I'm gonna get building and I'll see you guys once it's done. Alright, welcome back fellas. So, this is it. It's rather simple using the basic technology. I didn't want to overkill the design using part which is gonna be, in the end of your career. From top to bottom, this is a cockpit, standard cockpit. I put an drone core as an excess, let's call it something extra, to provide us with more reaction control. This is a crew cabin in case you got contracts for transporting people up and down. Small cargo bay in case you want to use this SSTO to launch a satellite, and a docking port as well. The rest is fuel part. I used the MK liquid fuel fuselage to provide extra fuel for the engine on the flight, and the rest will be liquid fuel and oxidizer for the main engines. So on the back we have 4 engine, 2 whiplash turbojet engine and 2 swivel liquid fuel engine. The wingspan is rather, this is an overkill to be honest, but it will do. The wingspan is around 8 pieces with 3 controlling surfaces in the back and 2 controlling surfaces on the front. And we have 2 delta wings to keep the plane going straight forward and yawing at the same time. We have 4 elevons. Most important while you're building is to, let's say, keep the build dry, so there is no fuel while you're building. And once you finish your build, you can just fill up all the fuel to see where the center of mass will be when the airplane is full of fuel. So as you can see, the center of mass has moved a little bit forward. Okay, fantastic. The center of mass is exactly in front of the center of lift. Now I made some adjustment to the last delta wing here. This adjustment in order to keep the plane, let's say, floating instead of rolling always. So even if you left the control, the airplane would go to 0-degree roll while it's flying. Alright, so let's give this birdie bird a chance to fly and see how will it go. Oh, most importantly, I almost forgot, we need to activate or to put custom control for the engine. So I'm using 1 for the turbojet, 2 for the liquid fuel engine, the main engine, sorry, swivel engine, and we already have some space for RCS. Let's fill it up and add some space maneuvers. So RCS system will be here. Alright, simple SSTO is ready to go. Let's shoot. Alright, welcome fellas. So this is the airplane and it's ready for takeoff. I'll be using MakeJeb mostly in the flight because honestly I'm lazy. And let's get it rolling. So first things first, we will activate the turbo ramjet engine. We will climb up to around 15 to 17,000 meter, and from there we will accelerate until well, let's say the maximum velocity we can reach. Once we reach that maximum velocity, we will activate the swivel engine, the main engine, and climb up to the orbit. So let's get the main engine up and running, release the brake and let it go. So there we go, we reached our let's say ultimate altitudes for the Whiplash engine. It's around 15,000 meter. Now I will try to accelerate, provide us with more speed. I'll set the pitch to 10 degree. We might lose some altitude for now, but we will cover it up once we start accumulating more and more speed. Now as you can see, we are accelerating at 1G and the plane is a little bit shaky at the moment. Okay, so as you can see, we recovered now the altitude and we are starting our cruising flight. In the optimum SSTO, you want to cruise as much as you can and accumulate or start your orbit at the maximum velocity you can achieve. Now this design doesn't have much of power, but again, this is a basic SSTO. If you want it to be even more powerful, you can add 2 extra engine and that should do it, or use a different engine like the Raber engine or other engine which would fly at a higher altitude at a higher speed. Right now we are achieving the, let's say, the maximum velocity we can get. I will reduce it back to 5 degree to accumulate more speed, and once we get above 600 meter per second, we will probably get enough lift for it to fly. Well, it actually already got the speed. Okay, so now as you can see, we are picking up speed and we are picking up altitude as well. The flight started getting a little bit shaky. We are reaching supersonic velocity. We actually, at this altitude, at this speed, we are 2 times the speed of sound on ground level. So now we are reaching the 800 meter per second velocity. Our fuel status is good, so we spent around 1000 units of liquid fuel, and now it's a good time to start our climb. Let's set to 45 degrees and wait until the engine starts losing power. once it's dropped below 100 kilonewton of thrust, we will kill the engine and start the other one, the main swivel engine. Alright, there we go. So we use the initial velocity to change our apoaps into a higher orbit or a higher altitude, and now we're using the main engine just to push us a little bit forward. I'm going to reduce the climb angle into, well, to 20. Our fuel status is a little bit scary, but I'm sure we will make it. 800. To be specific, you need, for your orbit at 70 kilometer, you need approximately 2000 to 2200, depends on how you form your orbit, meter per second. So from what it seems, we are able to achieve it. We might even have some extra fuel left. Alright, so we have achieved our orbit. We actually pushed it a little bit forward. We are about 74 kilometer. We have enough fuel to continue the circleize. We just basically need a slight little push to achieve the orbit. And look at that. Kerbin. Marma Kerman and Long Kerman has achieved their first flight towards space using a rather small SSTO, which I would say likely not the best idea. Okay, so we have achieved the orbit. We will warp until our apoaps, setting the angle again to 0, and then start our acceleration. So we will have to be pointing basically toward our prograde and start the burn. So I'm using this angle to see where our orbit will be, and there we go, engines on. Alright, that's it, fellas. We have achieved an orbit. Well, we have merely enough fuel to return back, to be honest. So I'm gonna put the retrograde from now. And we actually have some extra liquid fuel just in case we decided to go to the space center. Now in your design, this is just a basic design, and I would say it's a heavy one. In your design, you can fit it to be exactly how you want. Like for example, I didn't put solar panel here because, well, this is a simple flight. We don't need much of power, and the power we have is enough for the return flight. I would advise to keep this section here from the crew cabin to the clamp or throne docking port fixable. So let's say your mission is just to take people up to space, so you need to delete those two to reduce the weight of the aircraft, and that would accumulate less fuel on the way up or down. And same in the opposite mission. If your mission is to take up a satellite, so you can remove the cabin and you can remove definitely the clamps, so you can use only the cargo bay. Again, that would reduce the total weight of the aircraft, make it even smaller, so it will be rather easy to control. Okay, so I will make the retro burn here. Oh my god, that was an overkill. As it seems, apparently we might have some extra fuel to spend. So I'm gonna wait until we enter the atmosphere. I'm gonna burn up the extra fuel which is left. We still have the RCS, which we don't need really. Alright, let's go. Now, as an optimum angle to let's say enter the atmosphere or re-enter the atmosphere, there is a lot of angle, depends on how big your wingspan is. Like for example, for a space shuttle you need like 45-degree angle. For this airplane, because it has a bigger wing area, I'm going to start the descent with 25-degree. If we need more or less, we will adjust it on the way down. So I've burned the extra fuel we have. Now all engine is offline. We switched back to the RAM engine just in case we need an extra speed to pick up, because I'm planning to land back at the Kerbal Space Center, but that doesn't seem to work, obviously. I'm gonna turn on the engine just in case we were able to pick up some speed, and I'll see you guys at the descent. Welcome back, fellas. So we have achieved our re-entry. It was rather simple actually, and we are running out of electric power because, well, we don't have a solar panel. We ran out of RCS system because we did not fill up the tanks. So yeah, alright, so now we are back into the atmosphere, but we are no way near to Kerbal Space Center. We have some extra fuel, but to be honest, that's like a no way home. It's not gonna be enough to bring us back to Kerbal Space Center, but I'm gonna give it a go. In case this didn't work, we're landing in the water. Hooray! As it seems, we run out of fuel and we are no way near our space center. So I'm going to land this bird back, and let's see if this thing was well built to a level that it's gonna land anywhere. You definitely don't want to build an SSTO that cannot land, yes. So we are diving in at a supersonic speed, and I guess I will flare here. This is a good spot for landing. It seems to be straight. Gears is already down. I'm gonna maximize the brake and flare. Okay, so landing angle is, the land is not exactly straight, so this is gonna get bumpy. We're landing at a speed of 150. That's more than enough for the glide. Brakes on. We're flaring again. Now I want to bleed the speed as much as possible, and once it's done we will touch down. So 100 meters per second. I'm guessing this is a good time now to land. And touchdown. 60, 50, 10, and the bird is landed. Alright. well, this was a rather successful flight. Marma Kerman and Ludwig Kerman has proved to the whole Kerman community that you can build a rather simple plane, take it up the orbit and come back. Okay fellas, so if you enjoyed today's video, don't forget to hit that like button, and if you want to see more of, let's say, Kerbal guides in the future, let me know in the comment below, and don't forget to subscribe to see more of my videos coming soon. Until then fellas, stay tuned.